Hello everyone, and welcome back. We've been talking about entropy as a measure to find out the impurity of the child nodes. And this is the first time that I'm actually going to be introducing the mathematical formula for entropy. And it's very intuitive and it's very easy to understand. So just let's go through the formula and then let's see some examples to make it clearer. So simply, when we talk about the definition or the formula for entropy, the formula for entropy is given here. Basically, what it says is it's minus Pjt, summation of Pjt into log of Pjt. So actually the formula is very simple. The most important thing that you have to calculate here is Pjt. Once you understand this, implementing the formula is not going to be difficult. So let's understand what is Pjt. So what it says here is that Pjt is the relative frequency of class J at node T. So what it means is that thinking about the example that we've been talking about, whether you can go out to play or not, J represents the value of the classes in the outcome attribute. Now, in that example data set, J takes value yes or no. So whether you can go out to play or not. So those are the two classes that are represented in the target column. So when you look at a given node, you can see that if there are 10 observations in a given node, what percentage of those are yes and what percentage of those are no. So in our example, J is going to take two values, yes and no. Pjt will be the proportion of observations in a node that belong to the class J. So if you had 10 observations in a given node and half of them had a value of no and half of them had a value of yes, then Pjt for no will be 5 upon 10 and Pjt for J is equal to yes will also be 5 upon 10. So what you need to do is when you want to calculate entropy, you look at a given node, you see that what are the observations that belong to the different classes depending on the number of classes that are there in the outcome attribute. You calculate the Pjt ratio and then you calculate the log of Pjt. And then all you have to do is you just have to sum over Pjt into log of Pjt for all the values of J and put a minus sign in front of it. So we will see some examples and that's when it's going to be much more clearer. And now remember, entropy is a measure of impurity. We said that. So when all the records belong to the same class, then entropy will always be 0. And uh, C is the number of classes that we have. In our example, C is equal to 2. And the maximum value of entropy, which is when a node is perfectly mixed. So for example, in the case that we are talking about, we have yes and no. So a perfectly mixed node will have 50% yes and 50% no. So that is the maximum impurity that you can have in that, in any given node for that tree. And the maximum impurity will be log of 2 in our case, where C is basically equal to 2. And that is why the maximum impurity in our example is going to be equal to 1. So let's calculate that and see how that works out. So what I've done is that I have taken two extreme examples to explain this. So one is when the node is perfectly separated. Perfectly separated means that it is either all yes or it's either all no, and perfectly mixed, which means that it's 50% yes and it's 50% no. So let's apply the formula in the two examples. Now, see, if the node is perfectly separated, then either it's going to have all 0, which means let's say all no's, and either it's going to have all ones. So in the example that I've worked out, the two values of the class variable, the class value in the outcome attribute are 0 and 1. Let's assume that. And then, so what it means is that either the node has all zeros or it has all ones. So which means that when you calculate the proportion of zeros, then it's going to be 1. Or if the node is completely all ones, then the proportion of ones in the node is going to be 1. Remember, Pjt is the proportion of class J in the node T. So what we're saying is that in a perfectly separated class node, we have Pjt is equal to 1. And then when you plug in the formula of entropy, which is minus summation Pjt into log of Pjt, you will see that the value of entropy turns out to be 0. So you can pause the video and try this out. Remember, the log that we take in the formula of entropy is always log base 2. I'm going to talk more about this in the class when we do the class workout example in Excel. But you can apply this and see that entropy will be equal to 0 for a perfectly separated class node. For a perfectly mixed class node, Pjt is going to be zero point 0.5 or 1 upon 2 for P0t, and P1t will also be equal to 1 upon 2. When you plug in the formula, it will be easy to see that the entropy turns out to be 1, which is basically the maximum entropy for a binary class example. Okay, so the maximum entropy here for a perfectly mixed class is going to be equal to 1. So these are two examples, and I'm going to go over the formula of information gain in the next video.